Hi everybody, how you doing? So welcome to this week's Serverless Coffee Break with James. I brought my cup of coffee. I hope you've got a cup of coffee too, or a glass of wine if you're in a time zone where that's appropriate. My coffee today, I have Storyville coffee from Seattle. I'm a big believer. They don't pay me to say this. I just recommend it. Storyville coffee. So today's topic I wanted to chat about was about how serverless impacts development teams. So we talk a lot about how the technology works, Lambda and all the various services and how you build things. But I don't think we really talk about enough just how it impacts the teams of developers that you're working in. And so send me your comments on this video or via Twitter and I'll see them on my screen. But I wanted to share with you what my experience was. So before I worked at AWS, I worked in a company where we built applications for startups, and these startups were VC funded and they had applications they needed to construct, and so that's what we did. And I worked with teams of developers to make those applications a reality. And what we found was we started a few years back building everything on EC2, and then we moved to Elastic Beanstalk. And there was like going from EC2 to Beanstalk and a few things you have to figure out, but obviously it's obviously much easier for application developers. And then after 2 or 3 years, we had about 20 or 30 fairly large applications we were supporting. And the problem was that was taking a lot of time in maintenance. So we were spending weekends patching EC2s and doing sudo-yum updates and all that kind of thing. And I was desperately looking for a way to make it easier. So as a business, we could scale more and get more clients and move on from these applications we previously built. So I discovered serverless actually by accident. I went to Serverless Conf about 3 years ago now, and I did a workshop and did the hackathon and really had my eyes opened about what you could build and how you could build out these applications very easily. So I took that back to these development teams I was working with, and it took a few months to get everybody really up to speed. And so educating your team is actually harder than it looks in some respects, because everyone's used to seeing new frameworks and new languages and new ways of doing things. And instead of this being something that's difficult and requires a lot of learning, it's actually fairly easy, but it requires quite a lot of rethinking in terms of just paradigm shifts. So I spent a lot of time with people where we built some sample application projects, and we experimented with building different portions of things and sharing those with each other. And by doing that, you could essentially take a lot of the heavy lifting out of developing applications. But when we worked with clients, one of the strange things was that you weren't building entire applications where you were shipping versions as much. You started basically just issuing features because you can build things in a very small way. So working with your stakeholders becomes equally important because you find that your release schedule becomes much more rapid and you're able to respond in a much more agile way. So we did this for 3 or 4 months for the first couple of projects, made lots of mistakes. We built things where they're too monolithic, we had the wrong type of database involved, or we just didn't construct things the right way. So there's a lot of learning just in the way this new model worked for us. But I noticed that some of the things that started to occur were really beneficial. So one of the things I found was that if you have teams of developers, that most of them have a preference for one language over another. It's rare to get a team of 8 to 10 developers where they're all using exactly the same projects in one language because you're building a monolith. With this, we found that we had really benefits of polyglot development. If you had some people using Python or Node or Go, it was pretty easy for them to use the language they preferred because they're just building functions. So it made it much easier to use the language that was appropriate for a given function. If you've got something where you're just passing JSON around, Node is a great choice. But if you're doing something that requires a lot of data-intensive work, then Python was a great choice. So our applications became much more complicated in terms of just having different runtimes for different use cases. And it meant we could make better use for our developers where they had strengths in those areas. Another thing we found was that in projects where we had offshore teams, that we often didn't want to share proprietary information about the applications to certain teams because of restrictions we had with NDAs with our clients. So it's very easy with serverless applications to give people very small chunks of work where appropriate and just have them work on that piece and then reintegrate it back into the main application. You didn't really have to share very much of the application, which was really beneficial in certain projects where we had sensitive clients. So we also found that once we got our architecture working well, we were building much more smaller functions. And another thing here is you'll find that your amount of code you use really shrinks a lot. So we found typically we were writing 50 to 70% less code on average. That once we got the architecture working, we could reuse code in other applications for other clients very easily. So if we had just code that would, for example, open a file or process an image or whatever it might do, if it was scoped correctly, the function would take some environment variables that was particular for that project, but the code itself is fairly agnostic and you could lift and shift it. So we started to build code libraries that we could genuinely reuse between different projects. Another thing we did was using much harder to service. If you wanted to stand up a NoSQL database, you might have to get a cluster or some instances and learn how to install some software and really commit to wanting to maintain that software over a long period of time. With this, if we wanted to use DynamoDB or Kinesis, it's actually just a couple of lines of YAML and a SAM template. So if I want to create a DynamoDB table, it's really trivial. I don't have to do anything at all to manage the service. And so that opened our mind to thinking about trying, why not have more than one database in an application? You don't have to always lean on one thing. You can have DynamoDB feeding RDS, maybe bringing Kinesis and somewhere else. And so with these services, they're all pay as you go. And it's really inexpensive to try different approaches to different things. And if they don't work, you haven't really lost anything. You can just not do it again. But if it does work, you've managed to solve a difficult problem very easily. With our developers, prior to going serverless, a lot of the time we had product managers like me at the time who were working with customers to scope out features. And one of the problems with that is that you lose things in translation through the different layers. So we've all tried agile development and got away from waterfall. But the reality is that requirements aren't as clear as you think. So when you talk to customers about building things, a product manager will put together a document, a specification, and give that to a developer group. And the developer group builds what they want. By the time you go all the way around, it may not be exactly what they want, or the customer may have moved on from that requirement. What we found here was that with developers working on features much more closely, because they're no longer managing servers and doing all that kind of thing, that they start to actually get closer to the customer request, and in many cases are talking to the customers directly. And by doing that, the developers start to build smaller and smaller units of work that they can give to the customer to see if this is exactly what they want, then the customer fine-tunes what they want to see. And you create this iterative loop that is much more useful in the end in terms of producing software that people really want to see. So when you think about some of these things very broadly, you notice there are certain themes over time that start to emerge out of these serverless projects that I think are really helpful if you're a development group. The first is cost. So with cost, you are, with serverless, really paying for what you want, what you use, and not paying for things up front. And so often when we talk about cost, you hear people comparing the actual transaction cost in this unit for unit basis. But I think there's a more complex conversation to be had. One is that if you're building software experimentally, which I really think you should be doing to solve many of these problems, serverless helps keep that cost incredibly low. Really, you can build a lot of things for almost free in terms of infrastructure cost. It's just the time it takes for developers. But as things start to scale, especially if you're building applications, it then becomes very easy to attribute the cost to certain customers and to figure out which customers are costing the most in the infrastructure and to work out your profitability and to figure out where you should optimize in that infrastructure. So that's very different to building out things where you have a selection of instances and you've got pre-installed software that you're having to manage and lots of fixed costs. Another side of that is scaling on demand because, since the rise of EC2, scaling is a big part of that, but scaling is not immediate. So if you're building applications, especially mobile apps and web apps, you have to figure out your scaling strategy. And this means building auto-scaling groups and really having some foresight into the amounts of traffic that you're expecting to see. With Lambda functions, and actually with architecture using a lot of asynchronous design, you have using a lot of services that scale on demand and scale for you. And so thinking about scaling actually takes much more of a backseat to what you're building. And so, I found previously that when you first start scaling with EC2 and with any sort of virtualized environment, you make a lot of decisions that when you first start to scale, you often don't scale well because the decisions you made weren't exactly the right ones. So the first time you scale an EC2 event, you have to change up the scaling groups and get that right. With Lambda, typically, even if you have very, very spiky traffic, it's not something you really have to think about very much until you hit incredibly high volumes. For most mobile apps and for web apps, you sort of put the software out there and it can scale most of the traffic for you. So some of the other things to work out with your groups, because it's not all just rainbows and gravy, you've got to actually figure out some things that are a bit different. So I wrote a couple of things down I thought when we first started trying this were interesting to us. The first was security. So in the EC2 environment, you're used to building subnets and VPCs and security groups and all this sort of thing. In the Lambda environment, actually the security layer is much more transparent to you because you have to write IAM policies for each function that give that function precise access rights to individual resources. And I think security much more in the hands of the application. Think about, when you build a function, I don't want to use star permissions or anything. I want to be figuring out what access rights does this function need. And if you scope everything correctly throughout your application, and you set your permissions at a level where even in databases, you have row level permissions you can apply, you can actually build incredibly secure applications that need very little maintenance on an ongoing basis. The second thing is observability. So although we're all used to log files and building out typical observable models when you have server-based applications, in serverless it's a bit different because you have servers that you have functions that scale up dramatically, and you may find you get a concurrency of 500 or 1,000 Lambda functions all at once. And so you do want to be thinking about observability up front throughout your design. So you see we've got X-Ray available. It's very easy to turn on your Lambda functions, and there are plenty of partner applications as well. What you don't completely ignore observability and wait until you scale up in production. You want to make sure that you're ready for production, but although the scaling is handled for you, you've got a plan for really seeing what's going on in your application. But it's not just about log files. It's about being able to trace application transactions all the way through the different services that you're using. So another couple of things we found just in the closing part of this were that a lot of this became incumbent on teams to become very comfortable with different architectures with serverless. And that meant building things where you have small functions talking to other services and a lot of event-based architecture. And so we could fill whiteboards with designs for things. And then at the time, we weren't sure if we were doing it correctly because, there wasn't that much in terms of reference architectures available. But once you get comfortable with this idea that you've got lots of different services and functions living together as an application, it becomes much more easier to communicate the next type of project and the next type of project. But it's definitely a shift. It's not just an N-tier design like many things we build. It can be fairly complicated. And leaning on services is a really important part of this because you've got all of these services that act like Lego bricks. You've got to plug those into your application in the right way. There's no point in building this stuff yourself. You just build it. With AWS, you might be using things like Stripe for payments or even Auth0 for Auth if you need to. So you get comfortable with playing all these services and building those in. But again, it creates this application architecture where there's lots of different moving parts. So that's really the topic for today I want to talk about. But I want to keep this as an ongoing discussion because it's something I really think is interesting for a lot of dev teams. So as you start to experiment with this with your groups, let me know how it goes. Tell me about the things you found that worked well, things that didn't work well. I'd like to keep the conversation going in with the community about how we do a better job to help development teams pick up serverless. So my name is James Bezic. So I'm a developer advocate with the AWS serverless team. And the important part of that is I'm an advocate for you, the developer. I'm not working for marketing. I work directly for the product team. So everything we build at AWS is based on feedback from our customers. So if you tell people like me or Chris or Rob or Eric or anybody else in my team of developer advocates, things that you want to see in our products, we can communicate that back to the development team, developer team and product teams to get those built into our products. So send me any questions you have on Twitter. I'm at JBSW or on email at jbezic@linkedin.com. And any topics you might have for future conversations next week. Otherwise, I hope you have a great weekend and I'll see you next time. And don't forget to enjoy your coffee. Thanks very much.